Welcome to this episode where we transform an iconic image into a playful Lego-style masterpiece. We'll compress the image, upscale it while keeping the pixelated charm, and apply custom techniques to mimic the look of Lego bricks. By the end, you'll see how to combine creativity and coding to turn any image into a stunning Lego-inspired mosaic. Let's dive in. All right, welcome to the next episode. In this session, we're diving into image processing and visualization. Let's start by importing the libraries we'll need. First, we have NumPy, a core library for numerical computations. It'll help us handle arrays and mathematical operations. Next is matplotlib.pyplot, our go-to library for creating plots and visualizations. Then we import CV2 from OpenCV, a powerful library for image processing tasks like reading, modifying, and analyzing images. We're also using Schemage, which is part of the Scikit image library. It's a collection of image processing tools built on NumPy. From it, we import I/O for reading and writing images, and Disk, which helps us create circular masks for processing tasks. With these libraries loaded, we're ready to start exploring images and building some cool visualizations. Let's jump into it. Now let's write a function to compress images while maintaining their aspect ratio. This is useful when we want to downscale large images for faster processing or simpler visualizations. Here's how it works. First, we define a function called compress that takes two inputs. One, mg, the image we want to compress. Two, npixel, the target size for the smaller image, defaulting to 32 pixels. Inside the function, we calculate the shortest side of the image using the min function. This ensures that when we resize, we preserve the original aspect ratio of the image. Next, we calculate the new dimensions for the image. We scale the original shape down proportionally to ensure the image doesn't look stretched or squished. This is done by dividing the image dimensions by the shortest side and multiplying by npixel. The result is rounded and converted to integers to fit the resizing process. We then use OpenCV's cv.resize function to actually compress the image. The cv.interarea interpolation method is perfect for shrinking images as it produces smooth, high-quality results. Finally, the function returns the compressed image, ready for use in our application. This way, we can handle images efficiently without losing their essence. All right, now we're diving into some really fun image transformations. Let's break this down step by step, starting with two key functions: upscale and Legofication. Upscale function. First, we have the upscale function. This is designed to enlarge an image proportionally based on a target factor. Here's what happens. 1. It calculates the shortest side of the image to determine the scaling factor. 2. Using that factor, it computes the new dimensions for the image while maintaining the aspect ratio. 3. OpenCV's cv.resize function is used to enlarge the image, this time with cv.internearest interpolation, which preserves the blocky, pixelated effect of the original image. 4. Finally, the upscaled image is returned, ready for further processing. This function is great for creating that retro pixelated look or preparing images for more artistic effects. Next is the Legofication function, which turns an image into a Lego-style mosaic. Here's the process. The function takes two inputs, the image and the number of blocks, n blocks, to divide the image into, horizontally and vertically. It calculates a d-value that determines the size of each Lego block based on the smallest dimension of the image and the grid size. For each block in the grid, it finds the center of the block, samples the color at that center to represent the Lego block's color, draws three overlapping disks to simulate the raised Lego stud effect, one in light gray, offset slightly to mimic a shadow, one in dark gray, offset oppositely for depth, one in the sampled color, directly in the center. The result is an image where each region is stylized like a Lego brick. This combination of upscale and Legofication allows us to create blocky, colorful, and textured effects that transform ordinary images into playful Lego-like mosaics. Let's try applying these to an image and see the magic in action. We start by loading the image monalisa.jp using io.imread, which converts it into an array for processing. Next, the image is compressed to 32 pixels along its shortest side using the compress function, simplifying it into a blocky representation. After that, the upscale function enlarges the compressed image back to a high resolution of 2060 pixels, while keeping its pixelated appearance intact. Finally, the Legofication function is applied, transforming each block into a Lego-style piece with sampled colors and realistic stud effects. The result is a playful Lego-inspired version of the original image. Now, let's display our Lego-style image with a clean and polished look. Here's how it's done. We start by creating a figure with a 6 by 6 inch size to ensure the image is nicely framed. Using plt.imshow, we display the Lego-styled image directly on the plot. To keep the focus entirely on the image, we turn off the axes using plt.gca axis off, removing any ticks or borders. Lastly, we set the background color of the entire figure to black for a sleek and professional appearance. This results in a visually striking presentation of the Lego-styled image, perfect for sharing or showcasing the transformation. Finally, let's save the Lego-style masterpiece to a file so it's ready to share or use later. We use the io.imsave function from scikit-image to save the transformed image as a JPEG file named legomonalisa.jpg. By setting the quality parameter to 100, we ensure the saved image retains maximum visual quality without compression artifacts. The file is now stored in the current working directory, ready to be admired or used in presentations. Thanks for joining me in this episode where I brought an image to life as a Lego-inspired masterpiece. I explored compression, upscaling, and creative techniques to add the iconic Lego look. Stay tuned for more exciting projects that combine creativity and coding. See you in the next episode.